Okay. I'll talk about dark matter and neutrinos in left-right mirror model with discrete symmetry C2. In this poster, we are going to focus on the fermion and scalar sector. In the first, the table 1 shows the content of the fields of the standard model. Meanwhile, the table 2 shows the content of the mirror field. Chairs assignments had been proposed based on left-right symmetry and to properly cancel any anomaly. Note that the right and mirror neutrinos had been included. The breaking of the symmetry takes place in 2 stages. The first one is through the prime doublet scalar with its respective breaking expectation value, B prime. The second stage is the usual breakdown of the standard model with the standard model doublet with its respective breaking expectation value, denoted by B, as usual. Obviously, B prime must be larger than B. One comment in anticipation of the following slides is that the mixing between neutral scalar should not occur. On the other hand, the mixing parameter is very close to 0 based on the data reported by the HITS experiment. On the other hand, an important channel for the annihilation of dark matter will arise from the H prime. A detailed review of the model can be found in the reference shown below this slide. We show the interaction to introduce the channels between standard and mirror field. We will propose that the candidate for dark matter will come from the mirror sector. Another relevant channel for the annihilation of dark matter is given by the C prime. In the interaction Lagrangian between fermion and gauge boson, in principle, no interaction between both sectors is shown. However, after breaking of symmetry, a mixture between C and C prime will arise, which also has a suppressed mixing angle by the experiment. We can take it as 0 to isolate the standard model fermion from the dark matter. We want to have a framework that is as inert as possible. In the case of the potential in this model, it has been possible to reduce the free parameters. This is in part thanks to gauge invariant and the invariance from the parity symmetry imposed conditions on the mu parameters and lambda parameters. which P equals. At the end, we show the interaction that will give rise to the masses and mixes for the neutrinos, which we will discuss in the next slides. After the spontaneous breaking of the symmetry, we can write for the neutrinos the following terms that will provide their mass. There are mass terms for, note that there are mass terms for Dirac as well as Majorana. We can write the mass matrix for all neutrinos as shown in this slide. The notation has been simplified so that chi, pi, lambda, h, eta, sigma, m hat are 3 times 3 matrices. The term associated with sigma coupling, don't guarantee the stability of dark matter. For this reason, we must eliminate them. One way to eliminate these terms can be through introducing an additional symmetry. For example, we choose the usual C2 discrete symmetry. Based on the assignment of the values under this discrete symmetry C2, we can propose two scenarios that guarantee the stability of dark matter. In both scenarios, the assignment has been such that the standard neutrinos left and right are even, while the mirror neutrinos are odd. The difference arises from the assignment for the doublets. In the scenario 1, both doublets are even, while in the scenario 2, the standard doublet phi is even, meanwhile the prime doublet is odd. This assignment not only eliminate the unwanted couplings, but also eliminate other couplings that simplify the model. In this case, the unwanted couplings are the associated with the sigma. For the scenario 1, we show the result for the masses of the neutrinos. At this point, that remains is to diagonalize the matrix M light and M heavy for the neutrinos and the associated for the mirror neutrinos. This can be consulted in the reference shown in the below. For the scenario 2, the CISO mechanisms simultaneously consider the standard and mirror neutrinos. In this case, the results are also presented and ready for the final deionization process. Finally, we will comment on the analysis for dark matter, which is in progress. First, the particle that we consider to play the role of dark matter is the lightest mirror neutrino. Based on the scenarios presented previously, the channel for dark matter inhalation are as shown here. We have two channels, one from H prime, the heavy Higgs, and the other one from C prime, the heavy gauge boson C. Note that this channel excludes dark matter from any other standard model particles at this first stage. It is through a decay of this mirror fermion or particles to the standard model particle that it will have a signal. Currently, we are also studying this signal. Thank you.